Hi, everyone. We are working out of your textbook today. I am starting on page M2-10. That's M2-10. Okay, so the goal is to factor polynomials using ways that we've already learned about. We've done like the AC method, or just when the first coefficient is 1, you find factors of C that add up to B, right? So today, this is a pretty important statement. To begin factoring any polynomial, always look for a greatest common factor first. Those will make, if you're able to pull out a greatest common factor, it'll make the next factoring process much, much easier. For instance, if we were approaching this problem, maybe you would think, all right, since the coefficient is not 1, I'll use the AC method. So the AC method is where you multiply 3 by negative 36, set up this little diagram like this. So 3 times negative 36 is negative 108. Find factors of negative 108 to add up to 12, which might take you a long time to do. So what we're going to do instead is, instead of just jumping straight into the AC method, let's factor out the greatest common factor. So two students have already done this, Ping, I guess, and Shalisha or something. And so, hey, this guy pulled out 3x from each term and listed what remained. So remember, when you're factoring out, it's like essentially division. So hey, 12 divided by 3 for 4, x squared divided by x for just x. So everything right there looks pretty good. And you can check your work very easily by just multiplying to see if you get back to your original expression. So 3x times negative 12 is negative 36x. Like everything there looks good. This student, on the other hand, instead of pulling out 3x, she only pulled out a 3. So while 3 is the greatest common coefficient, it's not actually the greatest common factor because each one of these terms also had an x. So certainly this guy was correct. And the reason being, this person didn't actually pull out the greatest common factor. She only put the coefficient. She didn't take out the variable that is in each one of these terms. So for part B, completely factor the expression that they started to factor. So again, we're going to use this person's expression, and we're just going to continue factoring that. What that really entails is we have this 3x that had been factored out already, but we were also left with this trinomial, this kind of quadratic expression that we should be pretty good at factoring by now. So this x squared plus 4x minus 12, we're just going to factor this now. So to do that, we can find factors of negative 12 that add up to positive 4. So what are two things that multiply to make negative 12 that add up to positive 4? And that would be positive 6 and negative 2. Kind of hits both of these constraints here. 6 minus 2 is 4, and 6 times negative 2 is negative 12. So we have one more step here. I'm going to rewrite this expression like this. Just kind of preference, I like to group all the factors into parentheses. So we've got the 3x, that first thing that we factored out, the greatest common factor. And then this business right here, it becomes x plus 6 times x minus 2. And there we go. It is completely factored. So the idea behind greatest common factor is this process was much, much easier than trying to go through this process, the AC method, and eventually factor by grouping. All right, so for part C, use the factors to identify the zeros of the function 3x cubed plus 12x squared minus 36x. Then sketch the graph of the polynomial. So when you have factors, you can relate those to zeros very, very easily. You just set each factor equal to 0. So like 3x, that first factor, we'll set it equal to 0. The x plus 6, that factor will get set equal to 0. And x minus 2 also gets set equal to 0. And now we'll solve each one of these little equations. Like for this, we would divide each side by 3. And 0 divided by 3 is 0. So there's one of our zeros. This next one, we'll subtract 6 from either side. X is equal to negative 6. And then this one, add 2 to each side. And x is equal to positive 2. Fantastic. So hey, now to graph it, we know we have a 0 way out here at negative 6. we know we cross at 0. And we know that x is also equal to, one of our zeros is at 2. So our polynomial must look something kind of like this. It would increase, eventually bend downward to get through this origin, and then bounce back up. I know it's this direction because the coefficient of a here, this very first term, the leading coefficient, is positive, which means the graph's going to go positive. It's got positive end behavior in this direction. Okay, that should do it for this first page. Let's go to page M2-11. Try out some more of these. So for this, we are going to factor each polynomial function and identify the zeros, then use those factors to sketch a graph. And again, this is a very key point for today. Always look for a greatest common factor first. Not all functions are going to have a greatest common factor, but it's good to get into that habit to make other factoring processes easier on you. Okay, so the greatest common factor here, it looks like each one of these terms has an x, at least one x. So we'll go ahead and pull that out for sure. And then the largest value that can go into 3, 3, and -6, well, that would be 3. So 3x is our greatest common factor. Now in parentheses, what's left? If I take out the greatest common factor, what's left in this function here? So a couple ways to think about this, right, is 3 divided by 3. Well, that's just 1. And then x cubed divided by x is x squared. This next one, 3 divided by 3 is 1. X squared divided by x is just x. And lastly, -6 divided by 3 is -2. X divided by x, they actually cancel each other out. So that's it. That's our expression now. But we're still going to factor this even further. So we're going to try to find factors of -2 that add up to 1. What can we multiply to make -2 that adds up to +1? And so that would be 2 and -1. So these then represent our new factors of this expression right here, this thing in parentheses. So let's list all our factors out. We've got a 3x. We've got x plus 2 and x minus 1. So without having to set up all the equations, like I said, it's really easy to relate factors to zeros. Like in this one, x equals 0. For this, x plus 2 set it equal to 0. So hey, x must be equal to -2. And then our last 0 is going to be +1. You can just sketch those zeros on your graph. So we've got -2, we've got 0, and we've got 1. So we would go up, go back down, go back up again. And there is your polynomial. It should look something pretty similar to that. All right, moving on to part B. We've got 2x squared plus 6x. So this should be a pretty interesting one. Remember, the first thing that we're going to be doing today is pulling out the greatest common factor. So what's the largest number that goes into both 2 and 6? And that is 2. And then each one of these terms has at least one x variable. So we can factor that out as well. And what's going to be left is x plus 3. 2x squared divided by 2x is just x. And then 6 divided by 2, of course, is 3. We factored out one of these x's, only had one to begin with. So this term doesn't have the x. Fantastic. This one is linear. There's no other factoring to do. Like, hey, on this one, we ended up with a quadratic. So we had some more factoring. This one, again, is linear. No factoring necessary. I'm going to wrap this up in parentheses just because. So we'll have 1, 0 of 0. And then the 0 for this factor, x plus 3 has a 0 at -3. 0, another solution at -3. And this one is only quadratic. So it's not going to have this many curves, right? It's just going to be a parabola, which means it'll look something kind of like this. Fantastic. Moving on to part C. 3x squared minus 3x minus 6. Very similar to that first one that we did. But this time, not all three terms here have a variable. So we're not going to be able to factor out a variable. The 6 doesn't have a variable attached to it. So again, no variable can be factored out. We can still factor out a constant though. We can still factor out 3 because 3 can go into both 3, -3, and -6. So let's rewrite this function as 3 times x squared minus x minus 2. Okay, and then since this is quadratic and we can factor this one a little bit further, let's try to do that. So we'll have factors of -2 that add up to -1, which would be -2 plus 1. Remember, it hits both of these constraints. -2 plus 1 is a -1. -2 times 1 is a -2. So then we can rewrite this as 3 times x minus 2 times x plus 1. All right, almost done here. So the zeros would be x equals +2 and x equals -1. This 3 is just a constant. It doesn't add a degree to this function at all. It's like essentially the a value, just the stretch factor, and that's it. There's no variable, so there's no solution here. There's not an x attached to this 3. So again, there's no solution. So here our solutions were at 2 and -1. This one was also quadratic, so we're just going to be having a parabola. Droop down and then eventually start to come back up. All right, fantastic. Let's move on to part D. We've got a function, 10x squared minus 50x minus 60. And the first thing to do is factor it. So let's do that. Before we factor it, we're not going to do the AC method right off the bat because that would be 10 times 60 or 10 times -60. And then we have to find factors that add up to -50. And we're not going to do that. We're just going to look for the greatest common factor. So the greatest common factor here is 10. If we factor out 10, we're going to be left with x squared minus 5x minus 6. Again, I'm just kind of finding these things by division. -50 divided by 10 is -5, right? So this quadratic we can factor even further. We can find factors of -6 that add up to -5. So in order to do this, we would have -6 and +1. -6 times 1 is -6, and -6 plus 1 is -5. So we'll rewrite this function one more time. It's going to be 10 times x minus 6 times x plus 1. So if these are our two factors, we'll have solutions at 6, and we'll have another solution at -1. -1 there, we'll put the 6 over here. And this one was also a quadratic function, so it's going to look like a parabola. Droop down, come back up. And that is it. Remember, this 10 doesn't have a variable there, so it's not really a factor. It doesn't have a zero that goes with it. You can kind of just ignore constant values like that. Analyze the factored form and the corresponding graphs in questions 1 and 2. What are the graphs? Question 1 and question 2, parts A and B have in common that the graphs of questions 2, parts D and E do not. I am not even seeing an E anywhere. So let's just go ahead and skip that one. Write a statement about the graphs of all polynomials that have a monomial greatest common factor that contains a variable. So what it's saying is this greatest common factor that we pull out, what happens to their graphs if there's a variable attached to it? Like part D and part C, those greatest common factors did not have a variable. And notice that our function never crossed the origin. Now, if we take out a greatest common factor, and it does have a variable attached to it, like this one and this one, they do cross through the origin. And that's really all this question is getting at, I think. We're statement about the graphs of polynomials that have a monomial greatest common factor, like theta variable. So we could just say those functions pass through. Those functions pass through the graph's origin. They pass through the point 0, 0. Well, all right. That is 100% going to do it for this video, guys. Appreciate you watching. See you all in class. Bye-bye.